Hi guys, let us talk about the allocation of the population to the catchment area. So, in the previous video, I show you how to compute the catchment areas in different setting already. And now, assuming that we have the population here, so we have a lot of points here. Assuming that those points are mm, the mm, the buildings or the blocks in the cities. Uh, so, but we don't know. We knows the location. So if you look into the map and you can see the location of the building, but then mm, you don't know how much it uh, inside each catchment area. So if you have the catchment area here, we want to know like how many points within this circle and this circle and this circle, and maybe the combination of both. Okay, so that's why we have to allocate them or match them with the circle. So let us start with this situation first, and then uh, in order to make it simple, we just try to remove the collision area a little bit by bring this one down into 4. Okay, so if we have no collision, then it will be easier to talk about, and then later we deal with the collision. Okay, so in this case, we have the 4 areas, the 4 catchment areas, and then we have we need to match those areas with the population in here. So in this case, I just only need because I need matching with the tool. So I have a lot of fields here. So normally I wouldn't need everybody. So I only need the first one, which is the name of the shopping center, and the second one is the catchment area. So the rest I will ignore. So this one I will be underlying or catchment. Okay. So the name center. Okay, so this is the first, and then this is the second one. I think I need the name of uh, the area. I would name it into the block, so later we can uh, call them more easily. Okay, and this is the point. Okay, so in order to match this one, I need the matching tool in here. So the population, the underlying population or the universal will be come in here, and then the population will come in here the other way around. So if you don't want the crossing line, you can just move it around a little bit. Okay, so in here you have to choose the point in the catchment area, and then you choose like where the point or the target is. It's within the universe, which is the catchment area in this case. So after this, then I think I only need to get the point and then the center name, but I don't need the catchment area anymore. And then that's it. So if I run the workflow, it will look like this. So after this, you can see the population inside the different uh, shopping centers, right? Mm, there are a lot of them. And then these guys outside, these guys meaning that they maybe they in the ideal situation, in the real world situation, they will come anyway because a little bit far away, but they can still come visit or the shop there. But then mm, maybe they are in some situation they are too far away, and then they don't know about the existence of the shopping center due to marketing, and then maybe insufficient marketing effort, and then they don't know, and then they just stay outside. Okay, so these outside, and then these guys are inside. Normally, we were for the hard. This case is a kind of a hard assignment in which we have the cutoff, but in the situation, in the real world situation, we just assign each of them a number. So when you go far away, the number will be smaller, and then in the near center, the number will be bigger. Okay, so this is a computing model already, and then if you want to count the population inside each circle, you just use the summarize tool. So you group the population by the center, and then you can just combine the points together. So you can use a convex hull function to combine, but in this case, I just combine the point together in a layer. So I pose a layer, and then I just count the number of points within the layer, like how many points or how many blocks. This one is not directly translated into the customer yet, but it's potential because um, each population can each population pool can have sorry, a customer pool can have many customer. So for example, within your block, maybe it will have like one block, but it can have like 200 or 300 people inside the block, depending on the occupancy rate of the block as well. So we don't know, but can assume the number. But this count is the count of block, not the count of people. Okay. So in here, if you there are four layer. If you can select them one by one. So if you click one by one, and then Outlook will highlight the layer for you. So it's roughly show the population of each shopping center. So you can zoom out a little bit. It looks very crowded, but when you zoom out, it's like a lot of space inside with those in those building. It's very reasonable. It's like in your neighborhood. If you look into the Google Map and you zoom in, and then you see not many mm, not many like space in between, but when you make it bigger, let me try to introduce the let me try to introduce the light map in here, the light background in here, in order for you to see uh, the the underlying map, and then you see more clearly about what I mean by a lot of space inside. Okay, hopefully okay. So there you go. So if you see here, actually is a Singapore map, underlying map. If you zoom in, and then you can see a lot of you see like not a lot of space. Everybody is uh, next to each other, but yet when you zoom out, it's actually there are a lot of spaces between the buildings or between the blocks. This one is not a real data, by the way. This is the simulated data. I just randomly choose the places in Singapore in order to make sure that we have a lot of points, and then also the good points as well. In the real map, you can collect the points from Google Map or OpenStreetMap. Okay, so here you go. It take a while to render, but you can see a lot of space in here. The actual building block you can see also. So in here, for example, so in Topayo, you have 1, 2, 3, 4 buildings in here. Bishan a lot. Okay, 3, 4. Those are building. If you could see Google Map, and then you see more points. Okay, so that's the idea of again of matching or allocation. So you have um, okay, I have to turn off the map because the map it takes a while to render the map. Uh, so if you have mm, the centers, or you have the catchment areas, and then you have the population, and then you match them both together, and then you have more points in here. Okay, so let us do the mapping for the second case, because this one is bigger, so hopefully we will have the more numbers, let us see how the number comes out after after the experiment or the computation. Okay, so let me again just select the center, and then the catchment area I also name catch. So if I name the same thing, and later in here I don't have to change so much for my. Okay, so I want to make it line for line, two of them. So I will move them in here a little bit, and just copy from here to here. So it will look line for line for you. Okay, until here, I think. And then let me turn off the. And then in here, we do the same thing. And then I hope the number will be better. Okay, let us see how it goes. Okay, so in here we have around 1,000, uh, and then in here we only have few points outside. So this one, if the catchment area is this big, and then it will catch all the customer, and then almost nobody is outside the area. You have more customer, so in here you have only about 1,000, so 900 something, or almost 1,000, but in here you have more like 1.5 thousand, 1.5 thousand, so we have more customer. Okay, so that's how you match, or you compute the population within the catchment areas. And then this catchment area is not a random number. It's not like 2 and 7 you just assign like in our experiment. It takes a lot of work in order to build your catchment area. So you have to do marketing, you have to do your leading, like Google landing, or leading in the street, on the street, right? So you have to build a lot of pointings, and like shopping center 2 kilometers away, or this shopping center, this direction, a lot of things like that, in order just to make people aware of that. Oh, there's a shopping center near here. Sometimes people know that they are here, but they are too tired to think about it, and then if they see the signboard, they just come in. Okay, so it takes a lot of work in order to increase from 2 km, from this one is 4 km into 7 km. It's not that simple just to plug a number here, like what I'm doing here. Just put 7 in here, and then we have more customer. It doesn't work like that way in the real world situation. In computational method, um, we can do that easily, but in the real world, it takes a lot of effort. So the question here is how we bridge the gap between the two. So this is the reason behind behind this computation is, uh, if you just go from 2 to 7, you will have this much customer increase. So you increase from here to here. So you have more revenue, and then eventually you will have more profit. Uh, so the question is it worth it? Because it takes a lot of advertisement and a lot of tricks in order to point the customer to the shopping center. But is it worth it? If it's more customer, I mean more revenue and then more profit. But is not over, or is not like outperform the cost, then it doesn't make sense at all. So in order to answer the questions, you can use the computational method. In this case, a GSA method, or the geospatial analytic method, in order to produce a forecast number. This is not real. This is just forecast number, but at least you know that there are reference numbers to use in order to make the decision. So is it, should I go like 4 km, or should I go 7 km, or should I go like 10 km? So you have to make your own decision. But now, because of this geospatial analytics, you have more information, or you have more numbers in order to make decision.